Now let's understand the next concept where we are going to understand the centroid of a quarter circle. So again, I'm going to take the entire quarter circle into a first quadrant for simplicity purpose. Then the x bar and y bar will be positive. So let's draw a quarter circle here, students. I will take the x and the y axis. So we have the x-axis, we have the y-axis, and we have the origin, and this is a quarter circle. Now students, can you observe that this quarter circle at first instant might seem that it is not a symmetric diagram. Obviously, it is not a symmetric diagram about the horizontal and vertical lines. You got to understand that. The line of symmetry does not necessarily mean it has to always be parallel to the x and the y axis. Lines of symmetry can be inclined also. In this particular case, there is no horizontal or a vertical line of symmetry. But students, there can be a line of symmetry which can be inclined. Observe carefully. I can draw a line which is inclined by an angle of 45 degrees to the x-axis. It will divide this quarter circle into two equal parts. The parts has to look exactly identical to each other. So this line will be called as the line of symmetry. Now students, you can observe, I want to draw the centroid. I need to locate the centroid. So again, remember to locate the centroid for a quarter circle. I will take this as the radius r. Obviously, this is also the radius r. So remember that the centroid of a quarter circle will be again at distances 4r upon 3 pi from the two radii of the quarter circle. You remember in a semicircle, the centroid was at a distance of 4r upon 3 pi from the diameter of the semicircle. So here for a quarter circle, you remember that the centroid is going to lie at a distance 4r upon 3 pi from the two radii of the quarter circle. So if I draw, say, two lines parallel to the x and the y axis such that I know that the centroid is definitely going to lie on the line of symmetry. So this becomes the centroid G, that's x bar, the distance of the centroid from the y axis, distance of the centroid from the x axis, so that's y bar. So the centroid is going to be 4r upon 3 pi, comma 4r upon 3 pi. So here, if I now ask you the area of a quarter circle, you will say that the area is going to be pi r square upon 4, isn't it? And x bar is going to be 4r upon 3 pi and y bar is also going to be 4r upon 3 pi. So students, what have we learned here? We have learned how to find the centroid of a quarter circle. So always remember the note, the centroid of a quarter circle is going to lie at a distance of 4r upon 3 pi from both the radii of the quarter circle. So students, that was all about a quarter circle. Now let's proceed ahead with the next diagram, next shape, which is the sector of a circle. Students, now we are going to understand how to locate the centroid of a sector of a circle. Students, let's draw first of all a diagram. So again, I'm going to take a diagram in such a way that the line of symmetry for the sector is going to be the x-axis. Now observe this sector, which is of a circle, let's say this is the center, say O. You can easily observe that this particular sector will be symmetric about the horizontal line. So this is the line of symmetry, isn't it? So this line of symmetry I will take as the x-axis. Let's say the center is taken at the origin. So I can also draw for the y-axis, isn't it? So you can observe that the entire sector is not in the first quadrant, but still I can easily locate the centroid because I know that the centroid is going to lie on the line of symmetry. So the centroid is somewhere here, students. Let us see. This is G. Now you can easily tell the y coordinate of the centroid because the centroid lies on the x-axis. Its y coordinate is going to be how much? It is going to be 0. So I can directly write the y coordinate of the centroid as 0 for a sector. Now students, observe carefully. I know that this is the central angle, isn't it? This is a central angle, and let's take the central angle as theta. Then don't you remember that area of a sector is given by half r square theta, where theta has to be in radians. Students, when you're using the formula half r square theta, remember that theta has to be in radians. This is very important. You have to always remember that while using the formula for area of sector, half r square theta, theta must be taken in radians. Students, what I'm going to do here is, I'm going to take this semi-central angle as alpha. Let's take the semi-central angle as alpha. So you can easily identify that theta upon 2 if you take, that is nothing but alpha, isn't it? So the same area of sector now can be written as r square alpha radians. Remember, alpha has to be in radians. You got to remember the formula as r square into alpha radians. So that's the area of sector. Alpha is nothing but what? It is the semi-central angle. Alpha is the semi-central angle. Now students, I want to locate the centroid of this particular sector. So remember, the centroid is going to be at a distance of 2r sine alpha upon 3 alpha. That's the formula for the centroid. Its distance from the origin O. So that's x bar, students. It is the horizontal distance of the centroid, isn't it? From the y-axis. So remember the formula 2r sine alpha upon 3 alpha. But the most important thing that you want to note over here, alpha in the numerator, this alpha for sine, this sine alpha, this is in degrees. So the alpha in the numerator must be taken in degrees, and students, the alpha in the denominator should be taken in radians. Always remember this particular concept. The formula is simple. It is 2r sine alpha upon 3 alpha, but the alpha which is present in sine in the numerator should be taken in degrees, and the alpha that is present in the denominator should be taken in radians. So I can say the centroid G will have what coordinates? The centroid G will have coordinates. The x coordinate is going to be 2r sine alpha here degrees upon 3 alpha here radians, and very easily you can tell the y coordinate, it is going to be 0. What is alpha, students? Alpha is not the central angle. You got to remember that. You got to memorize that. Alpha is not the central angle. It is half of the central angle. So this was all about the concept or the centroid of a sector of a circle. So students, we have seen all the standard shapes now. We have seen the centroids for all the standard shapes. Now we are in a position to understand how to start solving some questions. So let's begin ahead with some questions, and before that we will see how to find the centroid of composite shapes. So students, let's proceed ahead now.